Today's lesson is going to be on recursive arithmetic and geometric sequences. First, let's start by defining what a sequence is. A sequence is an ordered list of numbers, like the example I've given here, 2, 4, 6, 8, 10. To refer to these terms in the sequence, we like to give them each a name. We call the first term, this 2, u sub 1. And then the second term would be u sub 2, u sub 3 for the third term, u sub 4 for the fourth term, u sub 5 for the fifth term, and we can use u sub n as the general term in a sequence. So whatever number we put in for n, it's that number in the sequence. So if we put u sub 100, it would be the 100th term in the sequence. For an arithmetic sequence, it basically means that to find the next number in the list or in the sequence, you add the common difference, or you add the same number every single time. So if we look at the sequence 2, 4, 6, 8, 10 again, we can see that each time the number is going up by 2. Right? So if we continued that pattern, 10 plus 2 would give us 12, 12 plus 2 would give us 14, and so on, and we could continue this pattern forever. Now we mentioned that the first term is called u1, u2, u3, 4, 5, 6, 7, 8, and so on, and then u sub n is the general term. We can also use this to write a recursive formula. So if we say that u sub n is the nth term, according to this we need to add the common difference to the previous number. So we would have to find the number that becomes before u sub n, which would be u sub n minus 1. Because if I plugged in 8 in for n, 8 minus 1 would give us the 7th term. And then I have to add the common difference. In this case, the common difference is 2. For all arithmetic sequences, though, we could just write d. So this formula is the formula that you would use for all arithmetic sequences. U sub n is equal to u sub n minus 1 plus d, which means the next term in the sequence is equal to the previous term plus the common difference. For a geometric sequence, to find the next term in the sequence, you multiply by the common ratio. So if we look at this sequence, we can see that by multiplying, we're going 2 times 2 is 4, and 4 times 2 is 8, 8 times 2 is 16, 16 times 2 would give us 32, and that times 2 would give us 64, and so on. Again, we can use our general term, u sub n, to find a formula for this sequence. We're taking the previous term, which again is u sub n minus 1, and this time we're multiplying by the common ratio, which in this case was 2, but in general we would call it r. So for any geometric sequence, this would be our formula, and so it's just u sub n equals u sub n minus 1 times r. To find the next term in the sequence, we take the previous term and we multiply by the common ratio. If we take a look at this sequence, first thing we want to do if we wanted to be able to find the recursive rule or any of the information about this sequence is we want to look and see what's happening. So if I look from 1 to 4, one way that I could get there is I could add 3 each time. And then I have to check, does that hold? If I add 3 to 4, do I get 7? And sure enough, I do. If I add 3 to 7, do I get 10? Yep. So each time I'm adding 3, so the next number in this sequence would be 13, and then 16, and so on. So for this sequence, if I wanted to write my recursive formula, I would do u sub n equals u sub n minus 1 plus d, but this time my common difference is 2, my common difference is 3, so for this particular formula, the answer for what is the recursive formula would be u sub n equals u sub n minus 1 plus 3. And we could write down that our common difference was 3, and that would be our answer for this problem. Now if we take a look at this sequence, I can see that from 2 to 6, I could add 4, but if I add 4 to 6, I do not get 18, I would get 10, so the plus 4 isn't going to work in this case. Another way that we could get from 2 to 6 would be to multiply by 3, and if I multiply 6 by 3, that gives me 18, and if I multiply that by 3, I would get 54, and the sequence would continue. Now for this one, since it's multiplication, we know it's a geometric sequence, so we would use the recursive formula of un equals u sub n minus 1 times the common ratio. And for this one, we know that the common ratio is 3, so it would be u sub n equals u sub n minus 1 times 3, and that would be our recursive formula. The sequences that we've looked at so far have all been increasing sequences, so I want to address what happens when the sequence is decreasing. So if we look at this first one, 26, 21, 16, we can see that each time we are subtracting 5 to get the next number in the sequence. So for my recursive formula for this one, I would have u sub n equals u sub n minus 1 minus 5. The important thing, though, to remember is that this is still an arithmetic sequence, and when we're talking about arithmetic sequences, we're talking about adding a common difference. So since we're talking about adding, we want to think of this as plus negative 5, so the common difference would be negative 5. It doesn't matter if you write the formula as u sub n equals u sub n minus 1 minus 5, or if you write it as plus negative 5. Either way is acceptable, but you need to make sure to write that the common difference is a negative 5, because that's what's going to tell us that the sequence is decreasing as it continues on. If we look at this next one, we can see that we're dividing by 5 to get from one term to the next. This is still a geometric sequence, which means that we have to write it in the form of u sub n equals u sub n minus 1 times some number, and when we're dividing by 5, that's the same as multiplying by 1/5. So we can write this as u sub n equals u sub n minus 1 times 5, which means that our common ratio, not times 5, times 1/5, which means our common ratio is 1/5. So even though we're dividing, it's still considered a geometric sequence because we can write it as a multiplication problem.